excited about sharing with you Robocompass. I am a university professor, an assistant professor at Valley City State University. I teach both online and face-to-face courses. I teach math for elementary teachers 1 and 2. I teach educational technology as well as some general math courses, anything from pre-college math all the way through calculus. So I have a wide variety of things, but what I most love doing is incorporating technology into any type of math class that I'm teaching, because I think it brings it to life in a way that sometimes hands-on can't do. So we covered Robocompass in my face-to-face class this semester. After we had talked about 4th grade standards with regards to angle measurement and then constructing angles, we brought it to life utilizing Robocompass a week later. My outcomes for tonight are to talk about what is Robocompass, if this is something new for you, who should use Robocompass, why we should use Robocompass, and then actually I'm going to get in there, we're going to show you how to start constructing utilizing Robocompass. So if you have an iPad with you or your phone, or you can split your screen and dual screen and have my presentation on one side so you can follow along, and then on the other side have Robocompass open, that would be ideal, so you can play along with. If that's not an opportunity for you, again, this lesson is going to be recorded and put on YouTube courtesy of Prairie Public, so you can come back and play along with it as well. So Robocompass is a free, I should point out, a free web-based tool for creating constructions using a compass, a straight edge, and a protractor in either a 3D or 2D environment. So you get to pick which environment you want to see the construction held in. It is completed using a series of simple commands on a grid. It has 10 drawing commands and 12 helper commands. The drawing commands can be assigned to labels, and then you can reference them in other commands. In effect, these commands can be combined in many creative ways to produce all kinds of geometrical constructions. The straight edge, the set square, the compass, protractor, and pencil graphics simulate the steps of the geometry construction for the corresponding written commands that you create, and it brings it to life every single step. So who should utilize Robocompass? Since the program is based on the coordinate plane, I would suggest incorporating beginning in 5th grade. 4th grade learners begin understanding concepts of angle, measurement, draw and identify lines and angles, classify shapes by properties of their lines and angles. So if a teacher were to have these pre-created and then allowing students to do things in 4th grade, that would be great. But I would think 5th grade, since you're just starting to graph points on the coordinate plane, would be the ideal age to utilize this with. Why should we use Robocompass? We know that coding isn't just responsible for, everybody's responsible for coding, not just one specific teacher. So you're actually coding the construction of geometry. We're able to visualize math concepts, which allows learners to see how the geometry is created. And when combining that with drawing on paper, would certainly support all types of learners, while at the same time facilitating mathematical thinking and conversation. I could also argue that Robocompass addresses most, if not all, mathematical practices upon integration. In addition, it incorporates the 4 C's of 21st century skills: the critical thinking, collaboration, creativity, and communication. Traditionally, if you were to use a compass when constructing, I noticed myself when we were doing this via paper pencil during class, I would say something like, put the pointy part of your compass on point A and draw an arc about this wide over here somewhere, right? It doesn't have to be exactly halfway. It could be about halfway or less than halfway. And draw your arc so that it's kind of over in this general direction. By utilizing Robocompass, we have to be more specific with how we're drawing things. A lot less abstract, but more specific. So today we're going to attempt to construct the following: an angle bisector, triangles such as a 30, 60, 90 degree triangle, a right triangle, and an equilateral triangle. as well as a hexagon. However, Robocompass can do so much more than the basics of geometry construction. It can do tessellations, transformations, dilations, and even trigonometry. So let's start navigating, and we're going to go to robocompass.com. Now, I'm going to be sharing this presentation with Prairie Public so that they can share it with you as well. So I have some challenges at the end if you're willing to try to do some extra things outside of what we're going to cover together. So I'm going to stop sharing this screen, and I'm going to migrate over to my Robocompass website. When you first come to Robocompass, in order just to get into Robocompass, you only just click Open Robocompass. Pretty simple. Once you're here, you'll notice that you have the ability to sign into your account if you want to save your work. If you don't want to save your work, then you don't even need an account to utilize this. But I'm going to sign in because there are a couple extra features that you can utilize when you sign into the account. Once you're able to sign in or create an account or using your Google account to sign in, you have a couple additional features for how you share it. It'll automatically share your stuff in your Google Drive. It automatically creates a file in your Google Drive, and it'll save your stuff right within your Google Drive so that you can easily upload it or share it with students or other people from your Google Drive. You can also share it as a live link or embed it in a website, which is really pretty cool. What I'd like to start with, though, as we take a tour, is to look at the examples. The examples give you a great idea or starting place of how to start a small project and how it kind of looks like on the left-hand side with our commands. You can name your work if you're going to save it. Otherwise, my favorite feature so far has been the how-to link. This tells us exactly what our drawing commands are and our helper commands are, depending upon what we're needed. And not only that, but it also tells us exactly how we need to actually type in with examples and what it means, depending upon what we're doing. And we're going to go in further detail with utilizing many of these different commands with the examples that I have that we're going to do together. Also on the left-hand side is a home screen. So as you touch the screen and grab your mouse and kind of wiggle it around, you get a really unique perspective, and sometimes you kind of get all wonky all around. So by hitting the home, it brings us back to the starting place. You can also do a full screen and toggle between 2D and 3D. You also can eliminate the grid as well if you just want a plain site. I like to use the grid because it's helpful. And I'm going to leave it in three-dimensional space. So let's start off by creating an angle. So each particular piece, if we're thinking about how we construct angles using pen and paper and a compass, every single step that we do needs a single step within our commands in Robocompass. So we need to start off by starting with a vertex. So I'm going to say that large letter A, is going to be equal to a single point. And I'm going to say, and notice as I'm typing, things are coming up. So it kind of tries to guess what you're looking for. And notice that I'm putting in a point, and it allows me to see how it needs the point to be programmed, how it needs, the command needs to look. I'm just going to put the point 2, 2. And we notice that it pops up in our first quadrant. I can even get a closer look at it if I'd like and kind of see how it looks. I'm just going to go back home here. Also, we'll notice off to the right, we can hit play, and we'll see that the pencil will come over and actually put a dot right on 2, 2 for us. There's some other features as well by highlighting, just putting my mouse over the point piece here. On the settings, I can change different colors. There's a different color palettes. I can also hide or show a label if I don't like it. And I'm going to talk about this label offset here in a little bit. I'm going to leave my label for now. We also need to create a line so that we can draw our angle from that line. So I'm going to say point B is equal to the point, and I'm just going to bring it off to the right-hand side a little bit, 0.120. So not exactly horizontal, just slightly off kilter. But now I need to connect those points so that I can actually draw my angle itself. So the new command is to draw the line. And I've been telling my learners to use the big letters for points and then lowercase letters for angle classification or lines, just to kind of keep the difference between points and lines. So I'm going to say little a is equal to line. And then we need to tell it where do we want it to go? Well, I want my line to go from point A to point B. And then it draws that line there. But notice that that little a over here is kind of in the way of the line and doesn't really make sense. So I want to see it a little bit. So I can offset my letter, if you will, here, so that it's not on that line. So if I need to reference it later, I can see which line I'm referencing. Or if you don't like it at all, you can just get rid of it. I'm just going to leave it there for now. Also, by drawing that line, my letter A for point A got kind of hidden. So I'm just going to off kilter just a little bit so that I have, so it's just a little bit so I can see it a little bit better. Okay. I'm also, if we need to draw an angle, we need to have a third point with a line. So I'm going to let point C be the point with coordinate 8, 11. And then connect that line, and maybe I'm going to call it line B is equal to line, this time I'm going to connect A and C together. B is not in the way at all. But now I've created an angle. That's all I decided to do, create an angle. I didn't say I had to create a specific type of angle. I just wanted to create an angle. But what if I want to find the measurement of that angle? Robocompass allows me to do that by typing find angle. And we have to use lines. So notice here it says the two lines of our angle. So I'm going to put between lines A and comma line B that we drew. And in will pop the angle of that, between those two lines that we drew. What's even more awesome is let's actually start and play this from beginning to end, and we can see how it takes shape as it goes through the different points. Also notice as it's going all the different tools that will come out and help us. Awesome. I find these to be really, really neat. Now let's take this line and let's copy this line. Excuse me, this angle. We're going to copy this angle. So we're going to make another 67 6/10 angle by copying it, utilizing our skills that we would use to copy if we were to do this pen and paper using construction. So we're going to create an arc with vertex A, and we're going to copy it to a new vertex, but we need to know what that new vertex is. So I'm going to label a new vertex letter D. Notice I'm just going in alphabetical order. You could go in whatever order you so choose, but I'm just going to make it off to the right-hand side somewhere. Let's say 16.4. I'm also going to recenter this a little bit. Okay. We also need a new beginning line that we need. So I'm going to also label point E off to the right-hand side. It doesn't need to be the same length, but let's just say we're going to call it 24.4. So notice that I'm exactly horizontal to it. Ooh. Kind of over here a little bit. The zoom button's cutting us off a little. And now I'm going to create this line. So this baseline here is now going to be this baseline here. So I need to create line C, and we're gonna let, well, maybe I'll just let it line D, since we start with vertex D, equal line from D to E. And then I'm going to offset it just a little bit so I can see it if I need to reference it later. Now we need to create an arc from vertex A so that we can copy that arc to vertex D. So I'm going to let E be the arc at point A. So my pointy piece is going to be at vertex A. I want to go a distance about halfway. So I'm going to have 5 units. The radius of this arc is going to be 5. And I'm going to go from the degree 320 degrees and I'm going to go 110 degrees, and you're going to see what happens. So notice it takes this entire arc all the way. Now maybe I didn't need to start at 320 down below. Maybe I could have gotten away with 330. So you can play around a little bit with the dimensions of how far you need to go with your arcs. But notice it needs to be a little bit more specific than when you are creating arcs just pen and paper, where you're like, oh, just kind of go all the way around, if you will. All right, so now I'm going to copy this exact same arc, but I'm going to start at point D here. So my new arc is going to be arc F, we'll just call it. So arc F is going to be starting at point D. We're going to go a radius of 5 units, just like we did, so it stays the same as point A. We're going to start at perhaps, maybe, since this one is a horizontal line, not a slanted line, I'm maybe going to start at 340 degrees, but still go 110. It's because it's kind of shifted a little bit. I now need to find the points of intersection. I need to know where this intersects over here. So I need to intersect a couple of things so that we can measure the same distance and copy that over. So I'm going to let point E, oh, we already used E. F is going to be the point, and this is where it gets pretty cool because I can use the word intersect. And I'm going to intersect arc E, comma, B, line B, and then close my parentheses. So then we see that that F here certainly made its way over, and I'm just going to move it up a little bit. So it's more in line there. So it created that intersection for us. I also need this intersection down here. So I'm going to let point G equal the point of intersection between E and A. Just offset it a little so I can see it. We're going to need to know where we need to put our pointy piece of our vertex, or excuse me, our compass. So I need to intersect F and D over here as well, so it knows exactly where to have that point. So we have point H is going to be the point of intersection between arc F and line D. All right, I need to know what is the distance between here and here, so that I know that the measure of the distance between here and here will be the same as well. So I'm going to create a new command, and I'm going to let, I don't think I've used a little g yet. No, this is going to be the point of intersection between arc F and line D. All right, I need to know what is the distance between here and here, so that I know that the measure of the distance between here and here will be the same as well. So I'm going to create a new command, and I'm going to let, I don't think I've used a little g yet. No. While we have this angle here, what I'm going to do is get rid of all this stuff on the right-hand side. We're going to get move to an angle bisector. I'm going to get rid of this. So starting with, we're still going to have our point 22, our point 12, 0. We have our line. We have the point 8, 11. We have our line B. So I'm going to create an arc C. Starting at point A. I'm going to go about 3 units long. 330 degrees is where I'm going to start, and then I'm going to move an additional 100 degrees. Then I'm going to let D equal the point of intersection. And I'm going to intersect A and C, and then move that down a little. And I'm also going to make the intersection on the top side. So I'm going to let that be E equals the point of intersection between C and B. And then move that out of my way. You can also hide them too, but sometimes if you're going to be referring back to them, I don't find that hiding them is very beneficial. I like to refer back to them at some point. Now we need to create arcs from point D and from point E. So we're going to draw small letter D as is going to be the arc starting at our intersect with point E. I'm going to go the same distance I did before using 3 as my unit. This time I'm going to go start at 330 degrees, but only go 60 degrees. Because we're kind of making a perpendicular, or I shouldn't say perpendicular, a bisector to point A. I'm going to repeat the following, but I have to think a little bit differently with my arc. Starting at point D this time, knowing that I have to intersect over here, where I start and end my degree values will be slightly different based on where I'm going. So it's still 3 units to keep everything the same. This time, maybe I'm going to start at 30 degrees and I'm going to move forward 60 degrees. Now you'll notice that I probably went a little too far on each one of these. I didn't need to go that far of a distance. That's okay. Have your learners play around with it a little bit. But we do need to know what this point of intersection is so that we can draw the line that goes through here. What I can do then is let F, we haven't used big F, F be the point of intersection between point our arc E and our arc D. And what's a really cool feature is that what we can put down is we can say, I want to hide D and then hide arc E, D and E, so that just we can see the point so it's not kind of in our way. And then I want to draw a line through to bisect. So perhaps I want to say, let's draw, let's say ABC, F is going to be the line from A to F, but I don't want it just to go from A to F. Perhaps I want it to extend a little further. So I can put comma, and then let's say 10, and it'll go 10 additional units past F, which is a really cool feature, or 10 additional units altogether, if you will. Maybe 10's a little too much. You can back it off. We can do 7. So it allows you to extend past a particular point, which is really awesome. We can also hide, let's get rid of that, so that we can actually determine what is the length of this angle and the length of this angle so that we know that they do in fact match each other. So I want to say find angle between line A and line F, as well as find angle between line F and line B. And although they're a little hidden over there, we certainly can move them around so that we do see that they are equivalent to one another, which is a pretty cool feature. I really like that, being able to find the angle. And then of course, if you were to run the whole show, it goes from start to finish, every single piece that we've done, including the hiding portions. I like that on the left-hand side, that with each particular piece that we're working on, it moves with it so that you can see which step it's doing as it's going along within the program. I love that the protractor comes out and we can see not only the protractor, we can see the compass, we can see the pencil, we can even see the ruler when we need to. There is a way within the settings that you can speed up how fast that it does each of these objects as well. So if this is kind of a slow pace for you, that's an option as well. Awesome. All right. The next one I want to chat about is up here. If I were done, I mean, we've done a lot of hard work. There's a lot of different steps to these, so we're just going to trash this and start over. I want to talk about constructing a 30, 60, 90 degree using a protractor and then using a compass. So I'm going to start with a line segment. So my line segment needs points. So I'm going to say P is going to be point -5 and 2. So we're going to expand into the the second quadrant, getting some negative numbers in here as well. That's like Q equals 0.92. And we're going to draw, this time I did keep them horizontal from one another. So I'm going to let P equal the line that's between point P and Q. And if you want to, you can certainly hide that line, show the label or hide it if you so choose. Just gonna back it off a little. So I'm gonna use the protractor at this point. So we need to create a 30-degree angle using P as the vertex. So I'm gonna let big S be the angle from P to Q, and I want it to be 30 degrees. Okay, so it creates that 30-degree angle, and if it helps you, we can put the protractor down, and it does create that 30-degree angle. But now I need to extend that a little bit past, because we're creating a 30, 60, 90 triangle. So I need to extend that line well past S in order for that triangle to be created. So when I draw my line of S is going to be the line from P to S, and I'm just going to extend it maybe 8. So I know it needs to go a little past that area of Q, kind of keeping in mind of how far. But if your learners aren't quite there yet, they can certainly extend it as far off as they so choose. So now that this is the 30-degree angle, and what we can do is also find that angle too, just to verify that between P and S, that it is 30 degrees, which it showed up really tiny over there. Just gonna move it out of the way. We're gonna create our 60-degree angle off of this side here. So I'm going to let T equal the angle from Q to P. So I'm going to start at Q. So from Q to P, I want it to be 60 degrees. Oh dear, something happened. Notice that I put it below the Q. So from the angle with which it's looking at, we're just going to play it so you can see how it's approaching it. It didn't go where we needed it to go. We actually needed to go, because it's going forward always, we needed to actually go backward negative 60 degrees. So when I move it to negative 60 degrees, it's going the direction which we need it to go. So therefore, I also need a line that connects but goes past point T. So from Q to T, and maybe we'll go 4 units. So now we've created our triangle. We also can check the angle between line P and line T, and we see it is 60. And we can also check the angle between line S and line T, and we should see it's also 90. You could also complete the triangle by finding the intersection and labeling that as a point. So perhaps you want to label U is the point of the intersection of line S and line T. And then you would also have a point there as well. All right, so in an effort to save time, we're going to skip doing the 30, 60, 90 using just a compass. Rather, let's try building an equilateral triangle so we can see some other things happening. And I also want to get to a hexagon, because I think a hexagon is really pretty unique to create using our features, the compass. So if I want to build an equilateral triangle, we're going to start over. So trash everything we've done, all of our hard work. Goodbye. We're going to start over. We, of course, need a line segment to start our equilateral triangle. So let's say point A is the point 3, 3, and B is the point 10, 3, and we got to connect them to make the segment. So A is the line between A and B. I'm just going to move this down a little. And B is going to be the arc starting at A. We know that an equilateral triangle has all sides that are the same. So I'm going to create an equilateral triangle that has a 7 for a unit size, because from the point A to point B is 7 units. So I need my arc to also be 7 units long as well. And I know that I need my arcs to be up here somewhere, such that I can draw my third point that are 7 units exactly. So I'm going to say that we're going to go start at about 40 degrees, and I'm going to move forward about 40 more degrees. So it might be a little too big, but that's okay. I'm also going to let C equal the arc starting at point B, also 7 units long, because we're creating an equilateral triangle. This time I'm going to start at about 140 degrees. So I'm going to start at about 140 degrees, but yet work backwards 40 degrees. Okay, so that you could move your angle forwards or backwards, however you so choose. And now wherever they intersect, I'm going to let C equal the point where they intersect. So the intersection of arc B and arc C. And it put it there, but we can hardly see it. So we're going to move it out of the way. There we go. We're going to draw a line. So I'm going to let D equal the line between A and C, point A and point C. And E equal the line between point B and point C. We can find the angle between A and D, which shouldn't surprise us that they should all be the same. A and E. We can find angle E and D as well. What's also really unique is that it allows us to find the length of sides. We have that ability to use a command to find the distance. So we can check the distance. To check the distance, we go DIST for distance. And I want to check the distance between 2 points. I want to check the distance between point A and point B. And it certainly tells me that it is 7 units. I'm just going to change the color so we can see it a little bit more clearly. I can also check the distance between point A and point C. And we also see that that should be 7 as well. And finally, I can check the distance between C and B, and we verify that it also is 7. So a pretty cool feature. This would also utilize the ruler so that we could check that it is 7 units long and so forth. All right. And the last one, which should take us through the end of our piece with time for questions that you might have. At the end here, my learners in 277 on campus had a really good time with this. We did have almost a 2 class periods worth of going over these examples together. And they were able to complete all of the challenges that are in the lesson that I have presented here tonight. And they did an excellent job. They played around with the different quadrants and placing them in there to see if they could still create it. They didn't just stick to the first quadrant, which was really great to see. But I think about all the different applications that this could potentially have, but we can talk about that in a second. Let's build the hexagon. And we're going to build a regular hexagon with side lengths of 3 units. So we're going to start again by creating a line segment that we're going to utilize. So I'm going to let A equal the point. Say we're going to start at 2, 1. I'm going to let B equal the point. We know it has to be 3 units long, so I'm going to let it be the point 5, 1. We need to find the center of this hexagon. So to find the center of this hexagon, I'm going to draw arc, B equals the arc starting at point A, going a distance of 3 since we have a regular hexagon with each side being 3 units, starting at 30 degrees and moving forward 60 degrees. I'm also going to let C equal the arc starting at point B, a distance of 3 units. I'm going to start this one at 90 degrees and move forward about 60 degrees because I need those pieces to intersect. I'm going to let O, big O, be the point of the intersection between B and C. Now we can hide these because we don't really need them and they're just going to be in our way. So I'm going to hide arc B, and I'm going to hide arc C so that I have just the center of my hexagon. We need to draw a circle around with a unit of a radius of 3 units. So I'm going to let little o be the arc starting at big O, going a distance of 3 units, starting at angle 0, going 360 degrees so that we get our circle. And we notice that A and B are automatically on that circle. But we need to create the other vertices of our circle. So to do that, I'm going to let D equal the arc starting at point A, going a distance of 3 units. So I'm starting here. I need to draw another one, so about over here. So thinking about the degree value of where I need to start and where I need to go, I'm going to maybe start at 100 and move forward 30 units. Excuse me, 30 degrees. So I can let this C be the intersection, point of intersection between little o and little d. There we go. And notice it's kind of all jumbled over here. So maybe just offset it a little bit so that we can see it a little bit easier. All right, now I'm going to let E equal the arc starting at point C, and we have to make an arc 3 units long somewhere over here, making our hexagon. So 3 units long. This time I have to think a little bit more, maybe start at 40 degrees and go a distance of 30 degrees. So then this could be point D, which is the point of intersection between O and E. And again, it's kind of not very visible. So we'll just kind of move it out of the way so we can actually see it a little bit. There we go. Starting at D, we need another arc over here. So we're going to let F equal the arc starting at point D, going a distance of 3 units, thinking about where it has to go. Maybe I'm going to start at 10 and go a distance of negative 30 degrees. So I'm working my way backwards. We need their intersection. So let's let F equal the intersection between, point of intersection between O and F. Okay. And we'll need one more to complete our hexagon before we can draw our lines. We now need to start at F and make an arc 3 units long about over here. So we have to think a little differently about the value of our degrees that we're going to have. So let's let G equal the arc starting at F, distance of 3 units, maybe 280 degrees going forward 30 degrees. And then G equals the point intersect O and G. There we go. And moving it out of the way just a little bit. All right. At this point, you could certainly hide all of your arcs if you so wish to do so. But so that we have some additional time for questions, we can connect our points. So continuing on with the little letters of the alphabet, I have seen some where they're using double or even triple little letters. So H is the line that connects A and C together. I is going to be the line that connects C and D together. J equals the line that connects D and F together. K equals the line that connects F and G together. And L equals the line that connects G and B. And finally, we can say that M equals the line that connects A and B together. And if we wanted to, we could hide little o so we can get a better picture of our hexagon. You could certainly find angles and find lengths, but I think about all the different ways that even though we were doing some pretty simple constructions today, that there certainly are a lot of different ways in which we could expand upon utilizing even these simple constructions. What do you think? Like, what are your thoughts about the program? What questions do you have?
Hi, Harmony. This is Kathy.
Hi, Kathy.
I'm just quickly plugging in my laptop before I lose power.
Oh, no.
But what a great tool. This has been so fun. I've been playing along with you while you've been doing it.
Oh, wonderful.
And I love how it combines geometry with the coding aspect, you know, where they have to be very carefully the programming.
Think a little bit more critically about where they're putting something. And every single step that you would do pencil paper is a single step on here. So it really kind of breaks it down into those individual steps.
Yeah, so I guess my big question, this all being brand new to me, was that how do you combine use of this program with pencil and paper? You know, would you have them do pencil and paper first, or?
I started my 277 learners with pencil paper first, and I emphasized notice each step that we're taking. And I had them say, notice that we drew a line from here to here. Notice that we drew an arc over in this direction. Think about all the steps that we're taking. And they said that was very helpful when we started doing this piece.
Ah, that makes sense. Yeah.
And I had them build the ones that we did pencil paper. I had them practice building it, utilizing what we've already done pencil paper, utilizing that using Robocompass and seeing the parallels on how they work really good hand in hand together. And it made it come to life for some of my not so artistic students who are a little bit more shaky on things. And for those students who like perfection, this really helped those who were perfectionists, if you will. They wanted that exact straight line. They wanted that exact perpendicular line. So I thought it was excellent.
As a lefty, I appreciate all of that. Not so dexterous, but love to see the good results. So you were showing at the beginning, and I think I was, playing around, but you were showing kind of a list of commands. Where was that?
It is on the top right-hand side under how to.
Okay. Oh, there it is. Yeah. I heard you say how to too, but I didn't see it. Okay.
Yeah, it goes all the way into like helper commands. So if you wanted to dive into like trigonometry and things like that, it has all of those pieces too. Granted, in 277, the highest level that we focus on is up through 5th grade math standards. So that would be well above and beyond, but it can create polygons. It can project and dilate things, and which we're gonna focus a little bit more on in 278 is dilations, because that's where those standards come into play. But I just think about other things that we could ask, like perimeter, and now that we have this built area, and like translating, how does that look if we were to translate this over some units? How would that affect how we're going to code it? There's a lot of things, like a lot of extension questions that I feel like we could go, even like proving the Pythagorean theorem if we were to build a right triangle.
Right. Yeah. So I'd be curious, whether the others have questions and what grade levels they represent.
Absolutely.
I can see using this in high school as well.
Absolutely. It's a useful tool, and I hope you have an opportunity to play around with it.
Yeah, well, this has been such a valuable session. Thank you so much, Harmony. I really appreciate you're a trooper doing this with a cold. I don't know if I would have been so strong, but.
I left school yesterday and I'm like, I gotta rest this voice up. But again, make sure you take a look. Everybody, whether or not you're logged into an account or not, everybody has the option to look at these example ones, and just taking a peek at noticing how they're coded on the left is a pretty interesting aspect to look at as well, because sometimes and I learn by example is my kind of thing. So if I can see what somebody else did and translate that into what I want to do, usually I can get it to work out. But they have a lot of really cool things, even if you're thinking of pre-calc with tangents and circles. I mean, tangents of lines and such like that. So like, I think it has means far beyond even the basics of constructions of polygons.
Mm-hmm.
So.
Well, again, thank you so much. I know people will appreciate this as they view it online as well. And I'm going to play with this.
Yeah, and I haven't found a whole lot of like YouTube related Robocompass tutorials, because when I first stumbled across this, I'm like, what is this really cool tool? So it was a lot of learning by doing and trial and error. So, well, thank you for allowing me to have this opportunity to share what we've been doing in class.
Yeah, and again, thank you. Get well.
Thank you.
This has been fabulous.
Thank
you. Good night.
Good night. Good night, everyone.